Hey folks, welcome to our new unit on trigonometry. Today we are going to work on an introduction by looking back at a little bit of what we did in geometry last year. So today we're going to be able to find any of the 6 trigonometric ratios of a right triangle. And you may be thinking to yourself, 6 ratios? I only remember SOHCAHTOA. I thought there were 3. Well, we have a few more for you, so let's take a look. So again, what is trigonometry? Well, trigonometry, simply stated, is just means to measure triangles. So the Greeks came up with this, and we've expanded on it since then to turn our trig ratios into trigonometric functions, and the study of waves, and all sorts of neat things that we're going to take a look at in this unit. So let's start by recapping what we've done before. If I have an angle in a right triangle, we'll call this angle theta. I know that across from theta is the opposite side. Across from the right angle is the hypotenuse. And then my third side is the adjacent side. So we have opposite, adjacent, hypotenuse. You may know this from geometry. And then we had 3 trig ratios that we studied in geometry. We had sine of angle theta, and that was opposite over hypotenuse. We had cosine of angle theta, and that was the adjacent side over the hypotenuse. And we had the tangent of theta, which was the opposite side over the adjacent. But we have 3 more that I'm going to introduce you today, and what they are the reciprocals of each of the 3 that we know. So the reciprocal of sine is called the cosecant. It's called the cosecant, and we abbreviate it. It's CSC. And then of theta, and it's the reciprocal of sine, so it is the hypotenuse over the opposite side. Next we have the reciprocal of the cosine, and that is called the secant, and that is SEC of theta, and so it is the hypotenuse over the adjacent. And lastly, we have the reciprocal of the tangent, and that is called the cotangent. And it is COT of theta, and that is the adjacent over the opposite. So we have our 3 original ones that we studied in geometry, and then we have their reciprocals, cosecant, secant, and cotangent that we are going to look at this year. So just to note, we can write sine, since it's the reciprocal of the cosecant, as 1 over cosecant theta. Likewise, we can write cosecant of theta as the reciprocal of sine. And we can write the same for our other pairs. So it's the same for our other pairs. Cosine is 1 over secant, secant is 1 over cosine, tangent of theta is 1 over cotangent, and cotangent of theta is 1 over tangent of theta. One way to remember what pair goes with what is an S is always paired with a C. A S is always paired with a C for sine and cosecant, cosine and secant. So let's take a look at this right triangle. We have 8, 5, and then we're missing our side here. How can we find a missing side of a right triangle? We can use the Pythagorean theorem. So, which is c squared is equal to a squared plus b squared. So c squared is equal to 5 squared plus 8 squared. C squared is equal to 25 plus 64. 89. So c is equal to the square root of 89. And I can't simplify that, so it will say square root of 89. So our sine value would be our opposite over our hypotenuse, and we need to find those. So I have my angle theta here, so this is the opposite side. This is the adjacent side. And then we have our hypotenuse. So if I want to find the sine of theta, it's 5 over root 89. But since we have the square root of 89 in the denominator, we can't leave it like that. So we need to rationalize the denominator. We'll multiply top and bottom by the square root of 89. And that's going to leave us with 5 root 89 over 89. Whenever we have a radical in the denominator, we need to rationalize it. So our cosine then would be our adjacent over our hypotenuse. So that would be 8 over square root of 89. And we need to rationalize this again, multiply top and bottom by the square root of 89. And that is equal to 8 root 89 over 89. Let's find our cosine. Oh, we already found our cosine. Let's find our tangent. Our tangent is our opposite over our adjacent, so that's just 5 over 8. And now we need to find our cosecant, secant, and cotangent. Since they are the reciprocals, we can just flip our fractions. Now I wouldn't want to flip our fraction that we rationalized because this would put the radical back in the denominator. What I want to do is flip our original ratio, our 5 over root 89, and flip that one. So now I have root 89 over 5, and I don't have to do anything else with that. So I've just taken the reciprocal of sine to get the cosecant. To get the secant, likewise I take the reciprocal of cosine, and I have the square root of 89 over 8. Reciprocal of our tangent is our cotangent, so that's just 8 over 5. So next we want to find tangent of theta if cosine of theta is 5/8. So what I need to do is draw a triangle. Let's draw a right triangle. I need to create our angle theta. Okay, and we know that the cosine of theta is 5 over 8. So that means that our adjacent side is 5 and our hypotenuse is 8, because then our cosine would be 5 over 8. Now I need to find the missing side, and again I can use the Pythagorean theorem to do that. So here I found that our missing side is the square root of 39, and now I can find the tangent of our angle theta because it's going to be the opposite over the adjacent, because that's what tangent is, opposite over adjacent. So our tangent of theta is equal to the square root of 39 over 5. In the same fashion, I can find cosecant of theta if tangent of theta is 3 over 7. So I can create my triangle. And just for fun, I'll put theta up here this time. So tangent is opposite over adjacent. So our opposite is 3, our adjacent is 7. This is a very ill-proportioned triangle, but that's all right. So now we can find our hypotenuse using the Pythagorean theorem. So I got that our missing side was the square root of 58. Again, I can't simplify the square root of 58 using a factor tree or perfect squares. If I could, I would, but I can't, so I won't. So I want to find the cosecant. Cosecant starts with a C, is the reciprocal of sine. Since sine is opposite over hypotenuse, I know that cosecant is hypotenuse over opposite, and it will be the square root of 58 over 3. Again, it's hypotenuse over opposite because it's the reciprocal of sine. Last thing I want to take a look at are our special right triangles. If I had the short side was x on a 30, 60, 90, the hypotenuse was 2x, and the long leg was x root 3. And on a 45, 45, 90, the two sides were x, the hypotenuse was x square root of 2. And so what I want to do is I want to finish up today by thinking about what would happen if I made my hypotenuse equal to 1. If I made my hypotenuse equal to 1, then that means my short side right over here, I would need to divide by 2. So my short side would be 1/2 because it's half of our hypotenuse. And then my long side would just be 1/2 times root 3, which is just root 3 over 2. If I made my hypotenuse 1 for the 45, 45, 90, how would I get to the short side? Well, I'd have to divide by that root 2. So if I do 1 over root 2, that would be my short side, but I can't leave it like 1 over root 2. I need to rationalize it, so I'd do root 2 over root 2, and that is equal to root 2 over 2. So my short sides would be root 2 over 2. Root 2 over 2. So I want to use these for the next exercise. So I had 1/2 root 3 over 2. Root 2 over 2. Root 2 over 2. And 1. So I've created special right triangles where the hypotenuse is 1. And so what I want to do is find sine of theta, cosine of theta, tangent theta, cosecant of theta, secant of theta, cotangent of theta of all of my different angles. My 30 and my 60, I get it from this triangle. My 45, I grab it from my second triangle. So we will take a look at this in class. You can try to do it now if you want.